Yeah, hi Karthik.
Yeah,
Is
hi
the
Santosh.
screen visible?
Yeah,
Okay, fine. So let's continue the neighbors discussion. Okay, so in the last class we have started understanding the basics of neighbors, right? So the main takeaways from the last class should be what is Bayes theorem, correct? So Bayes theorem is, as you can see here, it is just probability of any A by B equal to B by A into A by overall B, probability of B. Okay, it's the formula. So as I told you, so these are, yeah, sorry.
sorry. No, no, thank
Okay. So as I told you, so these are the technical terms which we use. So this is called the posterior. Posterior probability is what they call it as.
you.
Okay. And this is the main thing what we are trying to find out. So after that, we have seen few examples also. Okay. So the
Yes.
basic probability examples. Fine.
Yeah,
So then we have seen the what is contingency table. Okay, which
yeah,
and confusion matrix, etc. And then we have solved one good example, right?
yes.
So
Yeah,
fine. So now we'll just for better practice. So we'll solve this example and then we will see the actual code. Okay. So
okay.
the theory naive Bayes is not much. Okay. So it's just it's just called naive Bayes. The whole naive Bayes is based on Bayes algorithm. That's it. Okay. So
Okay.
given input and output, so you will calculate the probability of, okay, the output classes. Okay,
Yeah.
so that means what is the prop for a given row. So
Hmm.
if you see, mm, in logistic regression or SVM, so if given an input, so we are directly predicting, right,
Yeah,
class it will belong to.
correct.
So inside behind that also we have prediction, predict proba.
Yeah,
Okay.
correct.
So but here the whole concept itself is predict proba.
Probability. Yeah.
Okay. So just as a recap, what we'll do if given any new input, so this is we are going to solve. So for example, if you're asking for a new input, so we'll calculate what is the probability of this into yes, no, and what is the probability of yes. Okay. So
Correct.
and then whichever the highest probability that will belong to that class.
Correct.
Fine. So now over here, so usually what they say is, see, you are having this formula. Okay.
Hmm.
So what is P of A by B? So I'll just once copy this because this is very important. So the basic concept over here is, so when we do this, see, this
Hmm.
is P of A by B. That means
Correct.
what P of what is the probability of Y given
A
X?
at B.
Yeah. So for example, here if you see, if for example if you see the example, so we need to so what are the features? Outlook. Okay, that means
Hmm.
weather, temperature,
Hmm.
humidity, wind. Okay, and whether the kid is playing or not.
Correct.
Fine. So now if given this, okay, if given this, now if I ask for if weather is like outlook is sunny, cool, high, strong, what is
Mm-hmm.
the probability? Will the kid play or not? So that we need to find out.
Correct.
So now means what? So we are going to say, let me put it over. Yeah, okay, yeah. So now, probability of uh, given what is given, given
Given
this
is X.
x is given, and now I need to calculate y.
Y. Yeah.
Okay? So now this y could be no and yes.
Correct.
Okay, that means I need to calculate probability of
Play or not.
given x not play and also probability of given x yes play.
Yeah.
Okay. So now this is same as this one. Okay.
Correct.
So P of A by B is P of Y by X.
Hmm.
Now A could be, A is dependent on how many classes your Y variable is having, dependent variable is having. Here
Correct.
yes and no. In some cases, like I said, Setosa,
Three. It might be three as well.
okay. So for each individual class, you need to calculate the probability.
Correct.
Okay. And when you do that, the one which is going to give the maximum probability, that is your output final answer. So
Yeah.
that's why they say naive Bayes is nothing but it is a process of calculating the maximum posterior probability.
Correct.
Okay. So that's what they say. So in technically, what we are doing here is we are calculating the maximum posterior probability. Fine. So what is posterior probability? So this is given the input, what is the probability of output? Output could be multiple classes. Okay, in which class will be getting the maximum probability, that posterior probability. So that class will be the output classification.
Hmm.
Okay, fine. So clear till now?
Yeah.
Okay. So now coming here, so what we are going to do, so we know probability of n by x and y by x we need to calculate. Okay. So
Yeah.
now using this formula, okay, using this formula, right? So probability of n by x equal to what? It's probability
Probability
of
x by
n
n.
by I rate it like this.
Okay. Okay.
Probability
Okay.
of n by
Probability of
probability of
x.
because n by x, so I first write
Yeah.
off
Yeah. Yeah. Okay.
into probability of
Probability of
x by
x
n.
by n.
Okay, fine. So now similarly, probability of
Y
y
by
by
x.
x will be what? So it will be
Probability of
probability of y,
y by probability of
probability
x
of x into
into probability
probability of
of,
x given y.
yeah.
I need to calculate this. So now if you see both the numerators are p by x, so we don't
Correct.
consider this. Okay.
Yeah.
So we only consider p of n into probability of x by n, p of y into probability of x by y.
Yeah.
Okay. So now what is probability of n and y? So overall, how many you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. In
Hmm.
that 1, 2, 3, 4 are no. Okay.
Correct.
So the probability of n will be overall 10, 4.
Yeah.
Okay. So it will be 4 by 10 or 2 by 5. Okay.
Hmm.
And probability of y will be 1 minus this, or you can calculate it will be
6 by 10.
okay. So now we found P of n is done, P of y is also done.
Yeah.
Now probability of x by n and x by y.
Hmm.
Okay. So for example, if you see, yeah, so probability of uh I'll just I'll just rub this. This is 4 by 10 and 6 by 10, right? So let's remember that. Okay, fine. So over here we know probability of n. So now we need to calculate only two things: probability of x by n, okay, and
Hmm.
for x for no first will for this is for no, and for yes we'll see later. Okay, so now x is what? Now x is this. Okay, this is x we are given. So here that this is also probability of sunny by n. Okay,
Hmm.
into c probability of I'm just writing c by n
Temperature by
and
cool. Yes.
I by n. Okay, and
H
storm
by
by n.
n. Yeah.
Okay, so what is this
Hmm.
probability? So probability of sunny by n. So what is the probability of sunny by n? So given
Total.
n, given n, so given n are 4. Okay.
Correct.
So overall 4, how many times sunny is there? Okay, only 1,
Sunny
3, 4. So I think this is 1,
4 times sunny.
this 1, 2, 3 times. Here it is no rain.
Okay. Okay. Yeah.
Okay,
Two with respect to n, right? Yeah.
n.
Hmm.
Okay, so this is 3 by 4. Okay, all with
Correct.
respect to no only.
Yeah.
Now
Yeah.
what is this?
Cool.
Yeah, so over here also, if you see, the denominator will be with respect to y, so it will be
Hmm.
always be same. Okay,
Yeah.
it will always be same. Okay, so here also cool with respect to cold with respect to no is 1 2 3 4, so you can simply write by 4 here. It will also be by 4, it will also be by 4. Okay,
It's
now
only
cool,
one
yeah,
cool.
only one cool.
Yeah.
Okay, one. And humidity, humidity is high
Mm-hmm.
in no 1
Two
2
nose,
3
three.
knows. Okay, and what is strong? Strong with no
One,
1
two,
2,
two.
that's it. Okay, 2 by 4. Okay, so when you calculate this, what you get P of x by n.
Yeah.
That's it. This is what we want, right?
Correct.
Correct. So because the formula goes like this. So what was the formula? P of we need to calculate given x what is no probability. So
Yeah.
it is just we know the probability of n, we know, correct? Probability of n is this, and we're not considering probability of x, but we want probability of x by n.
Hmm.
Right now x by n is x is having 4. That's why you're taking 4 probabilities and each individual probabilities. When you multiply this and you multiply with p of n this, you will get one probability.
Yeah.
Similarly, when you do for p of y, you will get another probability. Okay.
Correct.
Whichever the value is more, so obviously that will be the answer.
Yeah.
Clear? I'm not doing the calculation, but
Yeah.
I
Yeah. Yeah.
get
Fine.
the concept, right?
Yes.
Fine. So now this is you can generalize this, right? So
Correct.
one advantage is it's very simple. As you can see, it is very easy to understand. Okay, when compared to logistic regression SVM, so there is not much max involved. Okay, not much complexity involved, right? So it's
Yeah.
just a probability. Once you understand the basic thing, so no matter how long or how many features you have or how many output classes you have. It's just calculating the probability, creating
Yeah.
the contingency table and calculating the probability. That's it. Okay,
Yes.
fine. So now, few things. Okay, before seeing the practical codes. Okay, so two things we need to understand. So first thing is like why it is called as naive. Okay, so it is Bayes theorem is fine. We understood it's called Bayes because it
Mm-hmm.
is based upon Bayes theorem, correct?
Yeah.
But why it's called naive? Because here it assumes, okay, it assumes that all the features are independent in nature. Okay,
Yeah.
and I
Okay.
would say this is one of the disadvantage of naive Bayes. Okay, so
Mm-hmm.
the reason why sometimes we don't use naive Bayes is it assumes that all the features are independent of each other. Okay,
Okay.
and usually it is not very easy to find out a data set where we are having completely independent features.
Okay.
Because in Titanic example also, if you see, if
Correct. If it
we,
is all higher class are saved.
huh,
Mm.
no, that saved or not saved is a classification.
Okay.
Forget about the classification, only features. So
Mm-hmm.
in features, what we have fare, we have
Correct.
ticket price,
Yeah.
we have class. So
Yes.
these are all not very independent. They're
Correct.
dependent because if it is higher class, the fare will also be high,
Here will be also high. Yes.
right?
Yes.
Correct. Like that, there will be some dependency between the features.
Correct.
But naive Bayes usually assumes that the features are independent in nature. Okay, naive means like there is no dependency kind of meaning. Okay,
Okay.
so that's why it's called naive Bayes. But still we use, okay,
Mm-hmm.
in most of the cases doing some assumptions. Okay, but strictly speaking, naive Bayes, why it's called naive Bayes, because it assumes that the features are independent in nature. Okay,
Okay.
fine. And secondly, there are different types of naive Bayes, Karthik. Okay,
Mm-hmm.
so usually there are actually many types, okay, but not all are famous, but mostly we come across this. Okay, so one is Gaussian, one is
Mm-hmm.
multinomial, and one is
Mm-hmm.
Bernoulli. Okay,
Okay.
it depends, like based upon your features we can decide, okay, which naive we can use. Firstly, if your features are to be a Gaussian distribution, okay, that means each feature, if it is forming a Gaussian distribution,
Mm-hmm.
okay, the normal distribution we have seen in stats class, right? So then we can use Gaussian naive.
Okay.
But if they are like discrete values,
Mm-hmm.
okay, discrete as in, not continuous. Continuous or what? Like weight is continuous. Okay.
Yeah.
It could be 3, 3.5, 3.4 like that. Discrete means what? How many people in a class?
Mm.
2, 10, 5. It cannot be 5.5, 4.5
Yeah.
plus.
Yeah.
Correct. How many vehicles do you own? I have two vehicles, three, not 2.5, etc.
Mm.
Correct. Exactly. So in those cases, if the features are in that way, we can go for this. And if the features are binary,
Mm-hmm.
okay, so then we can go for the binary valued feature of Bernoulli neighbors.
Yeah.
Okay, so these are different types of neighbors. But yeah, I would say you need to mainly remember the formula of this. Okay,
Mm-hmm.
usually what they write, I'll just show you. So usually when they write, right, neighbors formula, when they write it, so probability of mm, yeah, because, see, nowadays usually people, they unnecessarily try to use different words and they will confuse. Okay, but I will just show you one. Yeah, so over here, if you see suddenly, okay, this might look scary. Okay, so what? But it is exactly what we have
Okay.
studied. Sorry. Okay. Oh, sorry. Mm, yeah, let me put it here. Yeah. So over here, if you see, what they're saying is nothing special. So we have, we'll again use this. I'll put it here. Okay. So over here, if you see, they're saying probability of uh, output variable. Okay. C of
Mm-hmm.
k is output variable. Okay. Only the
Yeah.
label, the denotation is different. Okay. So
Mm.
basically, it is saying probability of given x.
Mm.
Okay. What is the probability of y? X could be
Yes.
many, x1, x2, x3.
Yeah.
Just
Yeah.
example we have solved. The x could be like sunny, cool, high school,
Mm-hmm.
any x. Okay. Where did it go? Yeah. Okay. So given all these x's, what is the probability of my y?
Yeah.
So this output, this is the probability we want to calculate for the naive Bayes. Okay, this is equal to probability of C of k. Okay,
Yeah.
probability of C of k by probability of all these x's.
Correct.
Okay, into
Mm-hmm.
probability of x by c.
Yes.
Correct. So over here, if you if I want to write this use and c and k, now can you tell me c by sorry x, right? C by x. What will be this probability of a by b means x by c, correct, into
Yeah.
probability of c by
By probability of.
x.
Yeah.
Okay. So here, see, probability of c, okay, probability of c into probability of x by c. So this is
Correct.
probability of x by c. So
Yeah.
this is pi. Pi means multiplication. So
For
the
all for
all,
all features.
okay, just like how we did like probability of sunny given no
Yeah. 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 Yeah.
into, we'll do multiplication, right? So that
Yes.
is multiply all from I to n, multiply each probability given this c of k. Now
Correct.
this c of k could be yes or no. Okay, first you
Yeah.
need to calculate yes and no. So if it is yes, then it is sunny given yes. Okay, wind given yes, like that. Correct? Yes.
Yes.
And z. Now z is what? Z is my p of x.
Mm.
By dividing by what? I'm dividing the denominator p of x. Okay, so where the evidence is z equal p of x.
Yeah.
Okay, and this is same this one. Okay,
Yeah.
so that's what. So usually when you come across this, right, so don't get scared. So it is same thing, but they're just writing in a different manner. Okay,
Mm-hmm.
fine. So this one I would like to show you. Fine. So after that, are you clear till now?
Yeah. Yeah. Clear.
Okay, fine. So then what we'll do is we'll go for an example. Okay, and we'll try to understand. Okay, so what we're trying to do here is, so as I said, using naive Bayes, right? So one interesting example is, like classification. Okay,
Mm-hmm.
document classification or sentiment analysis. Fine. So that means what? Given a text, you can classify into one category of section,
Okay. Got it.
or let's say whether it is a positive or negative. Okay,
Okay.
etc. So over here, if you see, let me take my pen. Yeah. So here, if you see, this is a text.
Yes.
Okay. So artificial intelligence advancing in healthcare with numerous application engineering. Okay, this is belonging to technology.
Technology. Yeah.
Like that, how many? Sorry,
1, 2, 3, 4. Total 4, I guess.
four. Okay, let me see. Okay, four. Entertainment, politics, sports, technology. Okay, fine.
Yeah.
So we're having four different types of output classes.
Hmm.
Okay, and these are their corresponding text.
Yeah.
So one thing, so the point is like given any text, so it need to classify into the corresponding label. Fine.
Yeah.
So this will try to solve using our naive Bayes. Okay. So
Mhm.
first thing is basic inputs. Okay. So which you are familiar. Next thing
Yeah.
is we are reading the data. Fine.
Mhm.
Fine. And if you see my data, so this is the data,
Yeah.
and X is my text data, simple. And
Mhm.
there are only two features actually. Okay, why? The point here is, see, we are having only one feature. As of
Correct. Correct.
this all, everything is one
Mm.
feature. Okay, so it's not like in Titanic example, you are having 10 features,
Yeah.
right?
Yeah. Yeah.
One feature, but from here we need to create features.
Yes.
Okay, that we'll see. So this is my Y. Y is my output. Now you are dividing it into train test split. Okay,
Hmm.
so this way familiar. Now the point is you cannot directly send this data to the model, obviously, right? So it
Hmm.
doesn't understand what is English, right? Artificial intelligence, it doesn't understand. So
Yeah.
you
Yeah.
have to convert this into features.
Okay.
Okay, so now converting this into features. Okay, so this is actually an initial step of NLP.
Okay.
So NLP is one separate branch, okay, in the
Mhm.
concept of data science. Okay, so as I said, we have machine learning, what we are studying. After that, you have something called as deep learning. Then you have NLP. Okay, it's
Hmm.
called natural language processing.
Okay.
So it is the technology where, okay, so we have the models which can understand the natural language, which is like normal spoken language,
Yeah.
English. Okay, but as of now, like it supports almost hundreds of languages.
Hmm.
Okay, so but the basic concept is making the computer understand the normal language which we speak, and we use it every day, right? So we have
Yeah.
Alexa,
Yeah.
we have Google Assistant, so
Correct.
almost everything, right? So, but now it is very very advanced. Okay, but
Yes.
initially, but like not many years back, just like I would say 10 years back. In 10 years back, when it started, right? So it was in very new stage, okay, very basic stage. Okay, then we are just converting the one which we are solving, right? When converting the any given text into some numerical value. Okay,
Yeah.
basic conversions. Okay, but now, as of now, we have very advanced, like which it can understand. Obviously, ChatGPT, anyhow, right? So it is just
Yeah.
understanding the human language,
Correct.
right? So it comes under this, like all the inventions till what we are having ChatGPT, right? So it comes
Yeah.
this bucket. Okay, we'll also see once we are done with ML, right? So we'll also take few classes on the NLP also. Fine.
Hmm.
So one fundamental thing in NLP is obviously the input will be in the natural language. Correct. So because it is NLP, so the point is to train a model which can work on the natural language. Fine. So that means what our input is going to be natural language.
Yeah.
Okay. So over there, but we cannot directly pass it as an input to the model because model does not understand what is English or what are these words. So you need to convert it into some features. Okay,
Okay.
convert into features. Okay, so we have different ways to convert into features. Okay, so the basic things are it's called encoding.
Okay.
Okay, so it's called encoding. That means we are just coding all the given words into some numbers.
Hmm.
So we encode them into some numbers. Okay, so we have different types of encodings, Karthik. Okay, so it's called a very basic thing we have called as bag of words. Just hear these terms. Okay, don't no need to worry about this. We'll see in future. But
Mhm.
we have something called as bag of words. We have
Okay.
count vectorizer. Then we have TF-IDF. Okay, so then these are basic. Then we have little advanced something called as what to wake. Then we have different kinds of embedding models like that. Slowly we now came into even in ChatGPT also, right? So when you send some question, it cannot directly understand it. So each word it will encode.
Okay.
Each word it will do some. It's called embedding. Okay, so each word it will try to do some embedding, and that means it will get converted into some number. So when you say, "Hey, tell me about AI," if you ask, so "Hey, tell me about AI," these 5 words it will convert into numbers based upon
Okay.
its training. So 5 numbers it will having each set of number. So you
Okay.
won't understand what those numbers are. It is part of training. So
Okay.
that number then it will try to match the nearest answer in its trained data set.
Okay.
The trained data set also that is also converted into number.
Okay. Got it.
So when you train it on one complete book, okay. So let's say you train the ChatGPT on a full book of 200 pages. Each
Mm-hmm.
word in that will be converted into some number
Okay.
and it will store it in its database. Now, when you ask a question, hey, what are the latest news in AI? So this question will also be converted into number. Now it's just a matching of numbers, matrices matching.
Okay.
Trying to understand?
Yeah.
Right? So the input question will also be converted into number. The already trained data set, its knowledge is also in the numbers. Now it's just matching the most nearest similar numbers, whatever it's matching. I'm telling in a very simplest form. Okay. So, but basically in the background, that's what matrix matching is what happens. Okay. That's why they say all AI is just nothing but matrices. It's internally there are like huge number of matrices. There's just matching, multiplications, summing. That's all it's happening. But when it is converting again it will convert it into the words.
Got it.
Okay. Fine. So now coming back. Count vectorizer is one thing, so which will try to convert our given text into numbers.
Okay.
Okay, and that means these are called vectors.
Mm-hmm.
Okay, so each row is converted into vectors.
Okay.
And why vectors means, as you know, a vector, for example, a vector is having a vector is in direction. That means 3 comma 4 means what? In x it is having 3, in x y it is having 4. In SVM class, I think we discussed this.
Yeah. Yeah. Yeah.
right? So 3 comma 4 means in one dimension its length is 3, in another direction it is 4.
Yeah.
Correct. So now what will happen over here is when we are, for example, you are having this, right? So if you, for example, if I take this, okay, now if I paste over here, okay, now if I divide this into text to and yeah, now you got different words,
Yeah.
10 words. This first
Correct.
row is having, okay. Now each of these word will be converted into a number,
Mm-hmm.
okay. So now the reason, now in the place of artificial you'll get some number, over here some other number, okay. So now,
Okay.
but now then it will become a, now this will become a feature, okay.
Yeah.
So here this is feature 1, feature 2, feature 3,
Correct.
feature 4, like feature 10,
Yeah.
okay. We have 10 features. Now as you know, each feature in machine learning is called one dimension,
Correct.
correct. So you're having 10 dimension, okay.
Yeah.
And now vector is also same thing, so it is also having different dimensions, okay. So that's why it's called vectorization.
Okay.
Clear? So it is, we are trying to, so now when we have like some, let's say some number 1 0 2 for something, okay, 10 numbers. So that means what, in first in this dimension the length is 0, in other dimension there is some length, okay, but it is in a 10 dimensional space. This one word is living in a 10 dimensional space.
And dimension. Yeah.
In each dimension its value is different, okay. So obviously
Yeah.
it's kind of vector.
Hmm.
Vector is also what, when you say vector 3 comma 4, that means what, in one dimension it is 3, in one dimension it's 4.
Yeah.
That's why it's called converting it into vectors. That's why it's called vectorization.
Okay.
Clear?
Yeah.
Fine. So now it happens. So it happens for each and every word. So basically in count vectorization, what happens is, see, I'll just give you a basic idea here. Okay. But when we are actually discussing the NLP, I will take a good example and tell you. Okay. But now in this example also, you will understand very well. So what it will do is, it will consider this sentence,
Mm-hmm.
take all words, 10 words.
Mm-hmm.
Like that, how many rows I have? 86 rows I have. 86 rows, it will take each row and divide into words.
Mm-hmm.
86 words, roughly, I'm just, for simplicity, I'm assuming each sentence will have 10 words. So
Okay.
6 into 10, 860 words I have.
Mm-hmm.
Okay. Then it will calculate the unique words.
Okay.
Correct? Because
Hmm.
there will be many repetitions, right?
Yeah. Yeah. Yeah.
Right.
Ease,
So
ease the everything
yeah,
will be.
is the and okay.
Yeah.
And even no, for example, you are having AI here. Here also you are having AI, healthcare, somewhere healthcare. Okay. There will be repetitions. So it will consider only unique words.
Okay.
So then it will have a list of from 860, let's say there are only 500 unique words.
Okay.
Okay. Now, all those 500 unique words, it will write it down. Okay. For example, I'm writing artificial intelligence is one word. And let's say world is one word from here. Okay. And let's say blockbuster is another word. Okay.
Mm-hmm.
And growing is another word. Like that, 500 words I have.
Mm-hmm.
500 unique words.
Yeah.
Now, what it will do, it will take the first row.
Mm-hmm.
It will see now first row is first word is artificial. Wherever artificial is there, it will put 1.
Okay.
Now, what is this? This is called intelligence. Yeah, intelligence is there. Yes, 1. Now, do I have, what is this W, world? Do I have world? See, this is world, right? So do I
Yeah.
have world in this first row?
No.
No, it will be 0. Now, what is B? B, I consider blockbuster, right?
Yeah.
Blockbuster. Okay. Now, I don't have blockbuster over here.
Mm-hmm.
Again, 0. Okay.
Mm-hmm.
For example, G is growing, right? So for example, here instead of emerging, there is growing. Assume. Okay.
Mm-hmm.
It will be 1.
Okay.
Correct. So see, this is my 500 is my overall set of unique words. Now
Okay.
it will see how many words from this 500 are present in each row, and wherever
Okay.
the word is present, it will put 1.
Mm-hmm.
Okay. Now 1 1 0 0 1. Let's say 0, all zeros. Now this is the my vector. These are my features for my first row.
Okay.
Okay. Now model will not understand this, but model will understand this.
Yeah.
It is just like encoding, right? Even in Titanic dataset also, gender, what we did, we are not directly sending male or female. We are encoding
Correct.
it 0 or 1.
Zeros. Yeah. Yeah.
Correct? Same thing we did, but different approach. So
Got it.
we have only two male, female, we did that. But here, these are like artificial, we cannot directly tell, right? So which could be 0, which could be 1. So that's why we use some other method, count vectorizer. But the result is same. We just want to encode it into some number.
Okay.
Clear? Same
Yeah.
thing next it will do for this football. So wherever
Mm-hmm.
the football is there, it will put 1 over there. And for example, artificial is not there in this second row. So 0.
Mm-hmm.
So not there, 0. World is there. Okay. So 1. This is not there. So like that. Agree?
Okay.
So like
Yeah.
that for all the rows.
Okay.
Okay. So then this will become its features.
Okay.
Clear?
Clear.
So this is one way of encoding the given input into numbers. There are
Okay.
other ways also, and this is very, very interesting. Okay, once we're studying, so you will find it very interesting. Fine. So we will discuss some other time. But the basic count vectorizer. So now count vectorizer is one method. Okay. So now, for example, if you see let me also see. Yeah. So when we're doing count vectorization, yeah. So count vector is technical that transform text data into numerical representation suitable for the machine. Okay. So it works by creating a bag of words where each word in document is related to a feature and the count of each occurrence is valued. Okay. Yeah. Correct. So document, fine. So it will also yeah, 100. Fine. I'm just seeing if there are any other way I can show you. Okay. So as I said, there is another vectorizer called as TF-IDF. Okay.
Mm-hmm.
So that is bit advanced than count vectorizer. Okay. And every new obviously is better. Okay. Count vectorizer is very limited, and then you have a TF-IDF, etc., etc. Okay. We'll see some other time. Fine. But that's the basic idea. Okay. Let's continue with the example. Clear for the count vectorizer?
Yeah. Yeah.
Okay, fine. So now what we have done, so we have just divided the data into X train, Y train, and then we see initialize the count vectorizer. Okay.
Mm.
So from where did we get this count vectorizer? So from sklearn dot feature extraction dot text, the count vectorizer is sitting in this.
Yeah.
Okay. And our naive base, here we are using multinomial naive base. Here naive base is sitting where inside the sklearn dot naive base.
Mm.
Okay, inside in sklearn dot naive base. Okay, fine. So now simple. So first is count vectorizer, and then this is my vectorizer object.
Yeah.
Count vectorizer is a class, so we are creating an object. So in this object, I'm doing what? Fit transform on my X train.
Yeah.
Because X train is my feature. Okay.
Yes.
So I'm getting vectorized, and we should also do for the test data set also.
Yes.
For testing, fine. So whatever you apply on train, you should also always apply for test also.
Yep.
Okay. So this you remember as general formula.
Yeah.
Not only this. So for example, you are encoding something. Any transformation you are applying on test data set, always remember you should also apply for training also.
Yeah.
Oh, I said in reverse. Okay. Any
Yeah.
you
Training
apply on
and
train, you should
test.
also apply for test. Okay. Fine. So, but one thing you should note here is while first time when you're doing it, you use fit transform. That means you are
Yes.
fitting, it will transform. Fine. But after that, you will just say transform.
Mm.
Okay. Because it's already fit. Right.
Yes.
So these are my X train vectorized, X test vectorized. So now I am only concerned about this X train vectorized and X test vectorized. I
Mm.
don't want this X train, X test.
Yeah.
Okay, fine. So now just if you want to see how it looks like, so X train vectorized. So these are actually, these are all just matrices. Okay. So for example, if I just write it, this is sparse matrix.
Yeah.
Okay. So sparse matrix, for example, if I use a shape. The 85. So here, 787. What is the shape of this X-train? 68. So oral out of 87, 85, 68 came into X-train. Okay. So
Mm-hmm.
now 68 into 395 sparse matrix of created. Okay. So with 787 stored elements in compressed sparse row format. So I think 68 rows it is considering.
Mm-hmm.
Okay. And each row 395. Okay. So in each row
395.
if I
The unique ones are 787. Huh?
yeah, let me yeah. So each one is having 395. Okay.
Yeah.
787. Yeah, I think 787 overall it's considering unique. Okay, so but I mean, see, how it is doing is no, not 787. No, it's not unique. Okay, I'm not sure what is 787, but 395 are unique.
Are each unique ones? Okay.
Yeah, that means it is considering 395 unique words. Okay, features, and in my extrain, so you're having 68 row.
68. Yeah.
So it is taking, and it will create 395 values for
Yeah.
it.
Yeah. Got it.
Zero is going to be one.
Mm-hmm.
Okay, wherever this particular first row is having the words in this 395, there you will have one, somewhere one.
Correct. Correct.
Remaining all it will be zeros.
Serious. Yeah.
Okay,
Yeah.
fine. So now, for example, if you see in this first row, so this is sparse matrix. You need to convert this into, you cannot directly see this. So when you say 2 array, okay, and if you take the first row, this is the first.
395. This is all related about first
Right,
one.
correct.
Yeah.
Okay, so these are all related for the first row.
Yeah. So
Extrain vectorized. Okay, so now
correct.
extrain first row. So over here we can see the first row. Sorry. Yeah. So the first is digital currencies and blockchain technology are revolutionizing finance.
Mm.
Okay. So this is the first extrain statement line,
Yeah.
and its corresponding matrix is this feature matrix.
Yeah.
These are called feature matrix. Okay,
Correct.
the only first one, right? So wherever you are having like 1, 2, 3, 4, 5, 6. See, usually it's having like 1, 2, 3, 4, 5, 6 main words, right? So I think here 1, 2, 3, 4, 5, 6, 7,
8.
8. Okay,
Yeah.
so 8 it considering. You can ask like why it is having 8, because because in future you will see in NLP, even though it is considering blockchain as one, so it will consider block and chain as two different words.
Okay. Okay.
Okay,
Mm-hmm.
so like that. Fine.
Okay.
So this is the representation. And for example, if you see some for 10th is like this is some other, and its corresponding feature is this.
Yeah.
Okay, fine. Similarly for the X test also, if I see for X test, this is a 10th row in X test.
Hmm.
Okay, this is the 10th row in X test.
Yeah.
Fine. And now white train is this one. White train is
Mhm.
technology or etc. etc. Fine. So now training is very simple. So first is we are importing the naive Bayes.
Yeah.
Okay. This is a model object dot fit. We are fitting on extrain vectorized and white train.
Hmm.
Okay. My extrain is what? Extrain is this extrain vectorized. Okay.
Yes.
And my white train is white train.
Hmm.
Okay. So we have this. Now training is done. So
Yeah.
internally we'll do the same thing what we have discussed.
Mm-hmm.
And then model dot predict. So
Yeah.
when predicting X test vectorized. Okay, for example, now why X train, right? So we'll take the X train. My model is ready. So what we'll do is X train vectorized. X train vectorized we will pass. Okay.
Yeah.
But we by seeing X train vectorized. See, for example, I'm saying this is my X train vectorized.
Mm-hmm.
Dot to array I will do. What's that? Oh, okay. So what I'm saying here is, so this is my extend vectorized. Let me take the first one, or yeah, first one. Okay, this is this.
Mm-hmm.
But I don't know what it is talking about. Okay, so that's why what we'll do, I will go with the extrain dot ilog of 1. Okay,
Okay.
so this is my statement. Robots and drones are becoming common in industry and logistics. Okay, what is this related to? Technology.
Yeah. Robots.
So this is
And also I can see
Hmm.
there is a 2 in place of, zeros instead of zeros and ones. I can see
Oh,
2.
is it?
Yeah.
In that case, that means it is repeating.
Okay.
Okay, so yeah, over here there should be some repetition. Robots and drones are more common in industry and such, and I think and is there, right? And
Mm-hmm.
is repeated 2 times. So it will count. So how many times? Okay.
Okay.
Right. So you're having the robots, drones, etc.,
Mm-hmm.
right? So if there is somewhere and is there,
Okay.
right? So the and is having repeating 2 times, so it will be two.
Okay. Okay.
Yeah, correct. So that's why it's called count,
Okay.
count vectorizer. So it will
Got it.
count how many. Okay, but that's a good example. So what I will do here is let me see if there are. Oh, sorry. Let me find if we're having any anyway. Repetition, sports, hiking, cycling. I've gained. It's hard to find, but. Here also any word where we are having 2 words repetition. Mm, The world of
We
profession.
can, I mean, even if two is TO, two.
But no, I can do that, but there is some concept called as stop words. Okay.
Okay. Okay. Okay.
So see, since we not study NLP, so I'm not telling that, but
Got it.
what
Got it.
happens is we have something called stop words. That
Okay.
means some basic words like to and actually. Okay,
Mm-hmm.
sometimes they get removed because they don't have any meaning, right? So of the
Oh.
all those get removed and remaining words only it will consider. Okay,
Okay.
so that's why I'm not sure whether two is considered here or not.
Got it. Got it.
Okay, so um, way we working. Yeah. But yeah, so wherever it is repeating twice that word, so it will give.
Yeah. Yeah.
Okay, fine.
Got it.
So once we see this, if possible, we'll only create one example and we'll write it and we'll see.
Yeah. Yeah.
Okay, fine. So now my point is my extrain of 0 is this. Okay,
Mm-hmm.
its corresponding vector is this.
Yeah.
Okay, fine. Now I know this is technology,
Mm.
but now if I pass this, okay, so now what I'm saying is I am passing model dot predict dot my extrain vectorized of 0.
Mm-hmm.
Okay. Is saying expected array of 2D array. Okay. Why? Okay. Now it's saying technology.
Mm-hmm.
See, usually when we need to pass in 2D, most of the time you will get is error because the
Yeah.
input you're passing, right? You should pass because you trained on a data frame.
Yeah. Got
Also,
it.
okay, when you're passing only one row, it will usually pass it in series. That means not
Yeah.
linear.
Yeah.
That's it.
Okay.
Okay. So yeah, so by seeing this, you can say this is technology. Okay.
Yeah.
So now the model is also saying technology.
Mm.
Okay. So let me take some other like 50 extra AI is enhancing. This is also coming as 10, or this is national teams are
All
finalizing.
it
This is both,
sports
right?
tournaments.
So
Yeah.
this is my corresponding sports ka related
Mm-hmm.
this one.
Yeah.
Now when I pass this, right? So I'm passing this and asking the model prediction. So the model should give me as sports.
Sports. Yeah.
Okay, fine. So this is by X train. Obviously,
Yeah.
train it on training data. Okay, but now if I go for X test and
Correct.
this is my political debate. So this is politics. Okay. So now instead of train, I'll go for test. Okay.
Mm-hmm.
So this is my 10th X row, test row.
Mm.
This is my its corresponding feature matrix. Fine.
Yeah.
So now if I pass this, to politics.
Politics. Yeah.
Okay. Clear.
Mm.
So that's how it's doing. But in Viprate, so sorry, this is it is because it is so now when you pass the whole, okay.
Mm-hmm.
Yeah. So when you pass the whole, so I'm just saying complete X test vectorized. When you pass it, the output predictions are
White bread complete. Yeah.
okay. So now one thing I would show you is here also we'll have predict proba.
Yeah.
Okay. So
Mm-hmm.
for example, over here, if you see model dot when I'm saying predict proba,
Mm-hmm.
yeah, if I take this example, so what is this X test politics example, right? So this is my X test, X test, X test. This is the politics. Okay. So now directly it is saying Viprate is politics, but instead of doing that, if I doing predict proba, so it is
Mm-hmm.
giving me the probabilities.
Okay.
Okay. And but what are these probabilities for which classes? So for that, you need to see, you cannot directly say because because in the first place you're having technology, no rule that the model is considering technology as a first place.
Correct.
So you should see how you'll see model dot classes.
Hmm.
This is attribute, right? So see,
First one is the entertainment.
politics, sports, technology.
Correct.
Maybe in alphabetical order, A, B, C, D, F, G, H, I, J, P, S, T. Yeah. So in alphabetical order, it's considering. Okay.
Yeah.
I think even when we do filter also, it is doing same thing. Oh yeah. So when we do filter also,
Mm-hmm.
I think it is doing that way. Right. So here, so whatever the probabilities you are
Here
getting.
9.96 is politics. So it
Okay.
got politics here.
Yeah. So 9.96 is politics. Fine.
Hmm.
So if I go for in test some other zero example,
Mm-hmm.
so I go for 0. So first I'll go for 0. Okay.
Yeah.
These are the different probabilities. And which is the maximum? Maximum is politics.
Yeah.
Okay. And this is politics. Yeah, political debate. Yeah. So now when I click on it should be politics. Okay.
Hmm.
Let me go for some other. Oh, it's not having. At AI mission. So this should be technology.
Yeah.
Okay. So I will go for 11. Okay. And when I do 11, so which is having more, 0.9 is more. The last one is technology.
Yeah.
Okay. So now when I give it 11 over here, the output will be technology.
Yes.
Clear?
Clear.
So directly we have predict. In predict prob also you can see these are the probabilities and classes.
Yeah.
Fine. So I think this is one example. So where you can get idea like how you can. There are only one extra step which we are doing here is we are also converting features also.
Mm-hmm.
Here you are directly having, for example, in Titanic dataset, you directly have the features. Okay. Features are given to you. You will just you can directly train it.
Correct.
The features are not directly given, so you need to convert it into features and then train it.
Right. Yeah.
Okay. And after that, same thing. So here also you have accuracy score, you have confusion matrix.
Okay.
Okay, everything. So when
Yeah.
you run this, see. So these are the 4 classes you have predicted true. So this is
True.
perfectly.
False. Yeah.
What was the accuracy actually? So how much is accuracy? Accuracy is 88.
Hmm.
Okay, that means there are some misclassifications. So this is misclassification. This is
Correct.
actually technology, but the model said entertainment.
Yeah.
Okay, here it is actually sports, but model said technology. That's it.
Except to
Okay.
comes under sports. Yeah,
Yeah.
that is fine.
Correct. Okay, so apart from that, everything is good.
Yeah.
Fine. So yeah, I would say you can take this as an example, or you will find many datasets. You can
Got it.
use a count vectorizer, convert it. Fine, and those. And in count vectorizer also there are different. There are few changes you can do. That means, see, as I said, the unique words are total 500. It is considering, right? So you can
Yeah.
put a cap on it also. That means I don't want 500. Consider only top 400 or 300. Based upon that, you can give me the prediction.
Okay.
Okay, so that
Got it.
you have control, so you can do all those. Okay, and yeah, so it doesn't much have actually any. I would say hyperparameter tuning is not much required over here.
Okay.
And count vectorizer, yeah, count vectorizer basic thing is enough as of now. So what we'll see is less. Yeah, I would say mostly this is one example, but you can extend this to different data sets also. For example, as I said, right, you open a restaurant and people gave you feedback. So all
Yeah.
the information you can scan it and convert it into Word document, and then you have the text. Okay, just like what text you have this.
Mm-hmm.
Right? So you have that text. Over here, what you will have, for example, a person is saying food is okay, delicious. Okay, then you can create the label for let's say 100 examples. Okay, so my example will be positive. Okay,
Got it.
okay, it's not clean. Okay, so it is negative.
Negative. Yeah.
Someone says just okay, so it is neutral.
Mm-hmm.
If you want 3, if you want only positive negative, that is also fine. So
Yeah.
now like that you can create like 1,000 features. Okay, and corresponding classes will be any 3, one of
Yeah.
3. Okay,
Mm-hmm.
and then you have this data set, and then you just
Correct.
pass it to this model. Fine. So you
Yes.
use the count vectorizer. It will give you the features for each
Correct.
one.
Correct.
Based upon your all the text, like 1,000 text, it will
Mm-hmm.
you get this.
Yeah.
And here the features. Now it's again a regular machine learning problem.
Correct.
You have the input features, you have the output variable, convert and calculate the accuracy, and then you change few parameters like how many words you need to consider or different types of naive Bayes algorithm if you want to explore. Calculate which one giving you the best accuracy.
Yes.
Okay.
Yeah.
Fine. So I would say, yeah, so that's about Naive Bayes, Karthik. So I hope you understood the basic. So there are only three things. So one is the probability concept you need to understand. Second thing is the Naive Bayes, okay, Naive Bayes formula. And that's it. So the text classification example, if you understand, so that will give you a good foundation for the Naive Bayes understanding.
Yes.
So yeah, so with that, I think we are good with the Naive Bayes. If you're having any
Mm.
doubts, you can ask me. Okay, fine.
Yeah.
And next, we are going to start with the decision trees. Okay, now next.
Sure. Okay.
Okay, chalo, we'll meet again. Bye.
Thank you.